Well, good morning, everybody. I'm going to start you off today with an animation of the last 12 hours or so of our radar. And as you look across the country, a lot of folks are kind of getting a bit of a break from what has been a pretty active go of it here over the last week. This is all a part of that kind of week on, week off time period. We're kind of in a week off right now. Now, that's not for everybody, but it's overall what the flow of the atmosphere is up to. So we watched one low kind of exit here in parts of New England. We watched another deep cyclone come into the west. It really lashed the west coast with a pretty strong front. And that low is going to go spinning its way today over parts of Alberta and Saskatchewan. And the concern about this is the strong winds it's going to produce as it just slowly moves through Montana and eventually gets into the northern plains of the United States later today and tomorrow. But if we just look back over the last 24 hours, this is kind of the United States and what we saw in terms of total precipitation. So outside of scattered showers that were on and around the Appalachian Mountains, clear up to Maine, and then the front that came into the northwest, that was about it. Now later today, we're going to watch for some very strong winds as that low curls up between Alberta and Saskatchewan. And you can see right in through here, we're going to have wind gusts that are easily in the 30 to some places approaching 60 to 70 miles an hour across parts of Montana. So extremely windy conditions today. But high pressure over the southeast, spinning like this. We're opening up the Midwest part of the United States and the central plains of the United States right in through here to some warmer conditions. And we're just going to keep an eye on this overall pattern. So this morning's cold air that was in parts of the central plains and Midwest here, we're going to watch a pretty sizable transition over the next week or so to much, much warmer temperatures in this area. And there's the high wind watches and warnings that are out for parts of Montana getting into South Dakota and parts of Wyoming as well. So I want to talk to you about something that I saw and I was asked a lot about yesterday. So I know on social media there's a lot of people that go out and just randomly post a lot of weather model maps, and you probably saw a lot of them that showed big time snows next week across the central United States. Now, I avoided talking about this yesterday on Monday on purpose, and despite some of the models showing big snow, we have to really take a very tempered look at the forecastability of these things, and it was only the GFS model that was showing it. So I like to show what I'm talking about. This is the newest update through next Friday, the 27th, looking at the forecast from this morning's 6Z run. That's the latest run we've got from the GFS. Showing you where the snow is expected. So notice it's Colorado, Nebraska. It's kind of this stretching through here and then another one through the Canadian Prairie. Now, the one thing I like about Weather Bell is I can go back and just show you the previous run. This was the 0Z run last night. That's usually the one I show you in the morning. It had massive snows in parts of the Dakotas getting up here into Ontario, and then, of course, throughout the Intermountain West and the whole spine of the Rockies. Now, the run before that, looked like this. Big snows in through Montana, getting out into the Dakotas, stretching up in Ontario. The run before that looks something like this. And the run before that, if we can get it here, this would be the 6Z. Look at that, all of that snow. And some of these models were even tossing out huge snowfall events very late in the time period coming across the Midwest. One of them yesterday morning put down, in fact, I wonder if I can show that to you, 12Z. There we go, look at that. I mean, it was trying to put down big snows in Minnesota and South Dakota. And then 2 days ago, it was trying to put it in Iowa. And I want to tell you something about these early season events. You might remember me being kind of critical of the GFS back in summer when it likes to produce in June these massive hurricanes that never manifest themselves. So sometimes when we look out there pretty far in the forecast time period, in other words, past about day 8, 9, or 10, and we see the model kicking out these big systems, we just we question it. And that's smart because we know that the GFS tends to go to high amplitude. Now, when I say that, what I mean is after a while in the GFS, it tends to take the trough ridge pattern. I'm just going to draw on the map, okay? It tends to take a trough ridge pattern that may end up looking something like that. But with time, it just makes it much more amplified, right? So that's the change in the amplification. And the more amplified it makes it, the bigger the systems that are going to be. In other words, you get a bigger contrast in temperatures, and as a result, bigger moisture exchange from the Gulf and then cold air from the Canadian regions, and it just blows up big systems. The GFS does that all the time. Now, I want to point something else out about the GFS runs that I think you need to see. So let's go back to the 0Z run. This is always the one I compare for you in the morning to the European model. You got your time up here, forecast hour. And as you play this out, you'll notice that the GFS runs out 384 hours, so 16 days. That's the operational run goes out 16 days. The European model, let me just flip over to it here, doesn't do that. The European model only goes out 240 hours. Now look, the European model is producing some snow in parts of the plains, in the Rockies, and a big event coming out of Montana. southern parts of Alberta through Saskatchewan and parts of Manitoba. So there is something there in both models, but it's all out there, way out there past, look at this. There's 7 days out right here. And we go out to day 8, 9. It's all out there day 8, 9, and 10. Now, why I'm trying to stress this, because we're trying to figure out if it's going to be there. So let's go do it, what we call the deprog DT with the European model as well. Now, it's only 2 runs that go out 240 hours or 10 days are the 0Z and the 12Z. So I'm not going to show you the 18 or the 6 because they don't go out that far. But if I look at yesterday's 12Z, you can see it's still producing something here, which means we have to start discussing this. But I'd like to show you why I'm always slow to show you these kind of maps, all right? And one of the great things that we do with our models is we verify them. Now, the European Center for Medium Range Weather Forecasting, that's what ECMWF means, they actually put together an entire web page of all of their forecast graphics and therefore their verification statistics. I can't find this for the GFS. I don't know. It may exist. I just haven't found it. But I want to click on verification, and I want to show you any of these graphics. You can look at them and study them and figure out the European model's skill scores. But I want to show you this one right down here. And I want to be very clear about how we use weather forecast models for predicting systems like this. So what we're doing is we're using the operational high-res European model, and we're doing an anomaly correlation coefficient. That, in other words, tells me how well did the model predict, what are we predicting? Geopotential height. That would be the 500 millibar trough ridge pattern. And we're going to look at a 12-month running average of its performance from the 1980s to now. So what happened was when this model was built in the early 80s, it was terrible. You know, it could only match the jet stream pattern at a correlation 3 days out. That's what this color means, at 80% accuracy. Today, it's almost 99% accurate at predicting the position of the jet stream 3 days out, the trough ridge pattern. Well, what about 5 days out? Back in the 80s, it was in the 60% range. Presently, it's sitting up here somewhere around 92, 93%. When we come out 7 days, these colors, and by the way, the envelope is northern hemisphere top, southern hemisphere bottom. Back in the 80s, it was 40% accurate, which means you never got a good 7-day forecast, whereas now it's 80% accurate. So what this says is that currently, our 7-day forecast has the same level of accuracy that a 3-day forecast had back in the mid-80s. But I need you to see this bottom curve, this one down here, because at present, the 10-day forecast from an operational run, which is what I just showed you from the GFS and the European, okay, matching the upper level height pattern, the thing that can be highly amplified in the GFS and then isn't even forecast beyond 10 days in the European, it's at 50%. So whenever you're on Facebook or whatever social media you're on, and all of a sudden someone who claims to be a meteorologist tosses out some wild forecast, and you're like, well, why isn't Snodgrass talking about this? It's because I've been trained not to. I understand the statistics of this. Do they happen sometimes? Oh yeah, they do. They absolutely happen. Sometimes the model sniffs it out early. But a lot of times, because of that performance statistic right there and everything beyond 10 days, I often am very, very cautious about telling you about it. What I have to see in order to tell you something about the weather beyond 10 days is to see if there is what we call ensemble support. Now, this model that you're looking at here is only a single run, the HRES, the high resolution one. That's this guy right here. This is the one we're talking about. But as you know, I often show you the ensemble. So what do? We take the model and we run the same version of it, just a little bit lower resolution so it runs faster, okay? But we run it in the European 100 additional times. So there's 101 ensemble members. Now what do? Each time it's run, we change something because the reality is the initialization of the model is flawed. We don't have weather observations everywhere. So to account for that potential error, they go through and they make small adjustments. And they see if the model still finds a big system or if it still goes in the same direction. And if that happens, that tells us that the likelihood of the outcome of that, current setup is higher. Does that make sense? The GFS does it 31 times. So the European 101, GFS 31. So let's go look at it, okay, after all of that. Now we know from the ensembles that the Pacific North American pattern is at a peak right now, and it's going to be at another peak by the time we get toward the end of this week. These are the big ridges coming into the west. But the ensembles very much agree, and that's what you're seeing, the ensemble spread here, that we're going to dip a big trough into the west at some point next Tuesday, Wednesday. Okay, so with that as knowledge, that there's good agreement among all of the ensemble members that the pattern is about to flip, let's go see what they do with it. So here is a forecast of the upper level height pattern. This is an ensemble average. So this tells me that more of the ensemble members are favoring the pattern doing something like this by the time we get into this weekend. Now, what just happened? Okay, we watched one little low go over the top and race up and eventually deepen here over the east, keeping a lot of cooler weather there and a big cyclone. I'll show it to you in a few seconds. This flow coming across the country like this is drier, except for where the low follows that black line through the middle of this week. That's all happening now. What we need to watch is this. That's a high amplitude event that is in the ensemble, ENS. And it is where we take a big ridge, a high pressure cell in the mid levels of the atmosphere, and toss it over a deepening low. That is a blocking pattern in the atmosphere, a high over low. And what tends to happen is the flow comes over the high and breaks the wave and dives. Now, when that occurs right here, this time of year, what we watch for is a rapidly deepening low across the western United States. So starting this Sunday and playing into early next week, there it goes. This is Sunday through Tuesday. Now, the ensemble suggests that there's two waves. There's a northerly wave here and a southerly wave there. And the northerly wave has a tilt on it in this direction. The southerly wave has a tilt in that direction. Now, what does that mean? That means that this southerly wave will likely get tossed around this side of the northerly wave that's going to dig into it. The net effect is we build a larger ridge out ahead, transport more water vapor, and more heat farther to the north to contrast that with building high pressure on the backside. The net effect is to produce a sizable low pressure system in the middle part of North America. And this is next Monday night, getting into Tuesday and Wednesday when those waves combine. And it's going to take multiple days for that to get out. But the only reason why it got there was because the jet stream moved into high amplitude and there was support for it in the ensemble. Now, this is the European model. Is it there in the GFS? Well, let's go have a look. Whoops, sorry. I have it. Let's go here. GFS ensemble right there. And this is the same time period from the 6Z run. If we compare the 0Z to 0Z, they're both there. So there is multi-model support. There's ensemble support, which means there's going to be a big system that comes out next week. But do we know the details about the snow? No, and the reason why we don't is because when you think about where snow is going to fall, I'm just going to show you this as an example. So this is not this system, but you see how all of the ensemble members are tightly tossing a low right here? There's a low. Now, if you're in the cold season, we typically have a cold front to the south and a warm front to the north. Your biggest snows tend to form right here on the backside, about 150 miles to the north, all the way to the northwest and west of the low. That's where you watch out for your snow. We tend to get ice in this area, thunderstorms down here, and a lot of heavy rain out ahead of it. That's how these lows are typically structured. Now, that's not what this one's going to do. Okay, this is the one that's producing all the strong winds in Montana. It's going to sneak into the northern plains and get right here over Minneapolis by the time we get out there to Wednesday night, and it's going to curl up into a much bigger low over New England. Watch it. Ready? So we see it going right there. Look at the size of that thing by this Sunday. Now, what we're doing here is we're out to Sunday. Now, we know our next big system is starting to show up next Monday night into Tuesday right there. Now notice the models, see all these different L's? Those are all associated with the 31 members of the GFS ensemble. So there's 31 of these representing each one of these systems. So there's one here and one here. So there's a tropical system here, and then we're looking at these L's representing the extratropical system. Now the setup is what I like. High pressure building in on the back side, high pressure building on the front side. So the flow comes around like this, same direction like that, and in the middle, that's where your low sits. See how they spin like that? So this tells me that midweek next week, next Monday night, Tuesday, Wednesday, we got to watch for something to be coming out of the Rockies. And if there is, in fact, high pressure behind it like this, that is the right setup. So let's just imagine your lows in here. That's the right setup on the back side for some snow. Now, if that low moves farther to the south, sure, the snow moves with it, but that's the current setup. But do you see how much spread is in the ensemble? That spread in the position of all these L's represents uncertainty. So we say, well, maybe the GFS has too much. Is the European model more certain? Well, it actually kind of is. It's got more of its Ensemble members sitting in here. Still, same big high pressure cell there, big high pressure cell there. So what this all means is there's going to be a big central United States system next week. And it does have the potential for putting down snow. Do we know where that snow is going to be right now? The answer to that is just no, we don't. We have ideas, and I'm going to show them to you in a moment. But before I go any farther, can I show you what the operational runs are up to? You see, this is the operational run of the GFS, the operational run of the European model, their highest resolution versions. And here comes the first low by tomorrow morning coming through the northern plains up here in the Red River Valley, well resolved by both models. It then slides over Minneapolis, gets to southern Wisconsin by Thursday morning, and then it starts to deepen later this week. There it is over the eastern Great Lakes. It's got a front to the south, heavier rains along the Appalachian Mountains, and this one's going to spin up, delivering rain in both models to the mid-Atlantic. After it passes through the southeast, you're going to see some scattered showers on the back side of it, and it's going to spin its way off to the east. That's the deepening low through this weekend. It's going to hit New England pretty hard. Now what happens is behind it, this is when the jet stream gets all bunched up. We have wave number 1 here and wave number 2 there. So again, it's in both models like this. All right, the southerly wave is going to grab whatever this tropical system is. Now watch, you got to watch two things. The tropical system, which is getting pulled by the southerly wave, and you're going to watch the extratropical system created by the northerly wave. So this is next Monday morning, getting into Tuesday morning. See the lows coming together in both models? And here they go. Now the GFS has a known progression bias. In other words, it tends to kick systems off faster. So this is where it is by next Wednesday. The European model says it's still sitting here. See that uncertainty even between these operational runs? This is the moisture plume from the tropical system in the European. Here it is in the GFS. And I'm going to take you back and show you those two things. Tuesday into Wednesday. The blue, though, is where the models are trying to toss in some snow. And you can see that they have both of them producing some snow. Now what's interesting is that the latest GFS run tries to throw out a secondary system right in through here by next Thursday. The European model has just such a large troughing event. It's got a lead system, a secondary system. It's pulled the tropical moisture into it, and it's a mess. And there's major model differences out this far. And they exist, and that's why we look at them, but we have to understand that all that we know right now, this is it, is that there is going to be a system next Monday, Tuesday, Wednesday, Thursday that evolves out of two troughs over the west and emerges on the lee side of the Rocky Mountains using the vorticity generated by the mountains to invigorate as it gets out into the plains. And it's there in both models, and it's there in the ensembles. But the details of this system are unknown. We cannot project where the heavy snow is going to be. All we can really do is understand which model is performing better, which right now, the skill score of the European is higher than the GFS, although the GFS made a nice little rebound this morning. And we have to remember that the models, when you look at their ensemble predictability, is where we really get the information about this. So what do we know? The next 7 days, it's really only the big system in New England. We have the one that sneaks over the top and comes through here, but it's not a big rainmaker. This is the chance over the next 7 days of getting an inch of rain. Watch what happens as we go from day 7 out to day 10. The ensembles are showing support for a larger system in the midsection of the country. So then we can say, well, show me the European model, same time. Now the European model is higher resolution, but you now see that it is also initiating that larger storm system. That's the probability of an inch of total precipitation. We know there's snow coming with this, so we can say, show me the probability of getting an inch. And now what we need to assess with this is that we don't know if there's going to be a heavy snow band here or there, although I think most likely it's going to be in through here and in the Rocky Mountains. We have to remember that the ensembles right now, when you look at all 101 members of them, they're giving higher chances of there actually being some accumulating snow after the system goes through the Cascades into the Rockies, coming out into Montana, Wyoming, Colorado, and potentially parts of Nebraska, South Dakota, North Dakota, and then here throughout the Canadian prairie. That's all we actually know about this system right now. Everything you see on social media where there's a big map of bright blues showing you where the heavy snow is going to be, a lot of that is just, those are just the operational runs that a lot of folks use for hype. So that's what we know. Now you know what I'm watching for midweek next week. We saw the deep low yesterday. Now we're getting a better idea as it's within about 8 days from now of what's going to be coming through. But that is why I always show you these maps. the day 8 through 14 CPC precipitation anomaly, the European Ensemble precipitation anomaly, and the GFS Ensemble. When all three of these maps look the same, my confidence is very high. The pattern is going to flip, the PNA drops to negative, deep trough comes into the west, and it opens up the Gulf, and a big system joins the contrast in temperature and moisture and rips across the midsection of the country. Now you see it. That's what week 2 looks like. Now the temperatures are going to respond in kind. Over the next 7 days, we have some patchy frost. We saw that already. But we're going to be watching for the temperature contrast to really begin to show up. So for most of the next 6 days, we're cooler east, warmer in the plains, warmer in the west. Ready? Here's today's highs getting into tomorrow. Now remember, this is when the little system sneaks through Wednesday into Thursday, getting here. Watch the heat come back into the west, cooler in the southeast, really the southeast, forgive me. And then we get into the weekend, there's Saturday, and this is when the big system blows up on Sunday. And by Monday, watch the warmth shift. There's the cold returning. We looked at it yesterday in the ensembles. So remember that now we know what that is. Here's the next 5 days. Day 5 through 10. Look at that change. Day 10 through 15. That's the pattern flip. Now what I try to do is I try to predict something like this happening way in advance. And we're terrible at that. I try every day to do this. It's a hard bit of science to predict the future behavior of a nonlinear chaotic fluid. But if you're curious why I've been worried about something like this happening, it's because forever I've been talking about the MJO. Know all this, right? The MJO prefers, when there's a positive ENSO event or El Nino, to go to phase 1 or phase 8, where it drops big troughs like that into the west. So for the last 3 weeks when I kept saying, gosh, I really think we're going to get to see some deep troughs developing because the MJO has just been stuck. Remember all these diagrams? It's been stuck sitting over here, sinking motion, rising motion phase 1, rising motion phase 8. That was my indicator. And all of that is built on the underlying factors, the seasonal factors of El Nino building, cold water in the North Pacific, negative PMM, and the Indian Ocean dipole. Because El Nino and the Indian Ocean dipole are causing sinking motion there, rising motion here and here, and that's putting some momentum into the Pacific jet, which is diving south of this colder water, invigorated by troughs coming off of the contrast in the colder water here, and it's just setting up a potent system there. So I just wanted to do some explaining today to show you why I go through all the stuff I go through every day. Fortunately, it's a Tuesday, and Tuesdays I don't typically have the most viewers. You like to watch the videos on Mondays and Fridays, so maybe some people will go back and watch this to kind of see what I'm concerned about. All right, one more thing. I should have brought these slides up, but I'm gonna go show you. Let's see here. Let's go to agweather.com, ag-wx.com. Slide down here. Go to South American maps. I've got no change for you overall in my forecast for South America. We're still seeing drier conditions here, wetter in southern Brazil. But the big thing is wetter conditions are now continuing to be forecast for parts of Argentina, which is, of course, in severe drought. This is an operational run, just so you know. But we can do this. Ready? We'll go here and we'll go WeatherBell again. And I use WeatherBell because I'm still building out my entire map library. And I love WeatherBell. I think it's a great website. We go to the European Ensemble. We're going to click on South America, surface precipitation 15. Let's do 10-day total anomalies. So it's in the Ensemble that there's support for the wetter conditions here, drier to the north. That's it. Okay. Have a great rest of your day, and we'll talk tomorrow. Thank you.